Hi, hello friends, welcome to the channel. In today's session, we'll be seeing Power Plant Engineering Unit 2 MCQs. Question number 1. If the working medium is a perfect gas, then what if a working medium is a perfect gas? This is the question asked. Option number A is given as PV is equal to MRT. Option B is given as PV is equal to RT. Option C is given as PV is equal to R by T. And option D is given as PV is equal to T by R. If the working medium is a perfect gas, then the only option is PV is equal to MRT is the right option. For working medium is a perfect gas. For perfect gas, PV is equal to MRT. This is you have to take up in mind, and you have to put a strong basement in that question. Option number 2. For question number 2, OTTO cycle consists of. Option number A is given as 2 reversible adiabatic and 2 constant volume process. Option number B is given as 2 reversible adiabatic and 2 constant pressure process. Option C is given as 2 isentropic and 2 constant volume process. Option D is given as 2 isentropic and 2 constant pressure process. Option number E is given as both A and C. We know what is A. 2 reversible adiabatic and 2 constant volume process. Our OTTO cycle is a adiabatic and has 2 adiabatic process and 2 constant volume process. The word adiabatic can also be called as isentropic. So option number C is also right, 2 isentropic and 2 constant volume process. So the correct answer for this question, OTTO cycle consists of, is 2 isentropic, 2 reversible adiabatic and 2 constant volume process, and 2 isentropic and 2 constant volume process. So I am going with option number E, both A and C. Question number 3. Diesel power plants are suitable for. Option number A is small and medium outputs. Option B is medium and large outputs. Option C is large outputs, and option D is none of these. What will be used for a diesel power plants? Diesel power plants are suitable for. In which condition will be using the diesel power plant? Will be using for stage performance. For some, if there is no power cut in our line, we'll be using diesel power plants for our home. In that conditions we'll be using. We are not going to be running a diesel power plant for manufacturing lots and lots of electricity. So large outputs cannot be coming. So I'm going with option number A, small and medium outputs. So diesel power plants are suitable for small and medium outputs. That is, household and stage performances will be using diesel power plant. So I'm going with small and medium outputs. For large production we will not be using diesel power plants. So option number B, C and D are wrong. Question number 4. Diesel power plants are of the range. Diesel power plants of dash range are used in central stations. Question number 4. Diesel power plants of dash range are used in central stations. Option number A is given as 2 megawatt to 50 megawatt. Option number B is given as 2 kilowatt to 5 kilowatt. Option number C is given as 10 megawatt to 500 megawatt, and option D is given as none of the above. But diesel power plants are used of dash range are used in central station. For central station will be using 2 megawatts to 50 megawatts. So I'm going with option number A, 2 megawatts to 50 megawatts. 5. Question number 5. The components of a diesel power plant are. Option number A is given as engine. Option number B is given as air intake system. Option number C is given as fuel system. Option number D is given as all the above. All the given engine, air intake system, for fuel system will be using for a diesel power plant. So I'm going with option number D, all the above. Without engine you can't manufacture, you can't bring mechanical energy. Without air intake system we can't fuel the engine. We need a fuel system also for a diesel power plant. So I am going with option number D, all the above. Question number 6. The compression ratio of diesel engine is. The compression ratio for diesel engine is. Option number A is given as 12 to 20. Option number B is given as 10 to 15. Option number C is given as 20 to 30. And option number D is given as 40 to 50. The compression ratio of diesel engine is. Option number A, 12 to 20 is the right answer. So I am going with option number A, 12 to 20. Question number 7. The compression ratio for OTTO cycle is. The compression ratio for OTTO cycle is. Option number A is given as 6 to 8, and option number B is given as 10 to 16. Option number C is given as 12 to 20, and option number D is given as 5 to 6. The compression ratio for Otto cycle, that is the petrol cycle, is 6 to 8, and the compression ratio for diesel cycle is 12 to 20. Please remember both of this. This is very important questions. This can be asked in association level engineering examinations. And the compression ratio for Otto cycle is 6 to 8. So I'm going with option number A, 6 to 8. Question number 9. The power extracted from the ocean energy is in the range of ocean energy. The power extracted from the ocean energy. This question comes in the probability in the first unit. Okay. Power extracted from the ocean energy is in the range of, option number A is 10 kilowatt per meter to 70 kilowatt per meter. Option number B is 0 kilowatt per meter to 80 kilowatt per meter. Option number C is 500 kilowatt per meter to 1000 kilowatt per meter, and option D is 600 kilowatt per meter to 800 kilowatt per meter. The power extracted from ocean energy is in the range of 10 kilowatt per meter to 70 kilowatt per meter. So I am going with option number A, 10 kilowatt per meter to 70 kilowatt per meter. Question number 10. The energy obtained by tapping the heat of the earth below the surface. This question also comes in the first unit. The energy obtained by tapping the heat of the earth below its surface is, option number A is given as biomass energy, option number B is given as geothermal energy, and option number C is given as chemical energy, and option number D is given as fossil fuel energy. The energy obtained by tapping the heat of earth below its surface. What is tapping the heat of earth below its surface? We'll be boring a deep hole. We'll be allowing water in it. Due to heat in the earth's surface, earth's crust, the water gets steamed, and that steam will be used to drive turbines. That is called tapping of heat of earth below its surface. What is biomass energy? Biomass energy is the energy obtained from biogases, that is methane. That type of gases is called biomass gases. So option A is wrong answer. Option number B, geothermal energy. What is geothermal energy? Tapping of heat below its surface. The word geo and thermal says the same. So option number B is the right answer. Option number C is use of chemical energy, that is of batteries. So it does not come. The option is wrong. Option number D is fossil fuel energy, petroleum. We will be extracting petroleum and using it in the surface, not tapping the earth heat. Tapping of heat of earth below its surface. We are getting it on the surface. So fossil fuel is also wrong answer. Option number B, geothermal energy, is the right answer. Question number 11. The process carried by the component boiler is called boiler. Option number A is given as reversible adiabatic expansion of steam. Option number B is given as constant pressure heat addition process. Option number C is given as reversible adiabatic compression process. Option number D is given as constant heat rejection process. What process does this boiler perform? In boiler, the pressure does not undergoes expansion. So option number A is wrong. Option number B, there is definitely heat addition in the boiler. We are going to add heat to the content in the boiler. So option B is right. Option number C, there is no compression in the boiler. Option number D, pressure heat rejection. There is no heat rejection. There is a heat addition in the boiler. So I am going with option number B, constant pressure heat addition process. Question number 12. The process carried by the component turbine is called. Option number A, reversible adiabatic expansion of the steam. Option number B, constant pressure heat addition process. Option number C, reversible adiabatic compression process. Option number D, pressure heat rejection process. You will be whenever steam strikes the turbine, what happens? The turbine blade rotates. There will be expansion process, expansion of steam. The pressure will be reduced in the inlet to outlet of this turbine. So there is an expansion process. So I am going with a reversible adiabatic expansion of steam. There will be an expansion of steam, that is reduction in pressure. Where if there is reduction in pressure, will be called as expansion process. If there is addition in pressure, will be called as compression process. So in the process carried out by the component turbine is called reversible adiabatic expansion of steam. So I am going with option number A, reversible adiabatic expansion of steam. Condenser. What the condenser perform which process? Option number A, reversible adiabatic expansion of steam. Option number B, constant pressure heat addition process. Option number C is given as reversible adiabatic compression process, and option number D is given as constant pressure heat rejection process. What is condenser? We'll be allowing cold water to in a tube, hot water will be coming. We'll be supplying cold water above the tube and we'll be trapping the heat and we'll be removing it. That is a process of condenser. So there is a heat rejection process. So I'm going with option number D, constant pressure heat rejection process. Question number 14, pump. Pump performs which process? Option number A, reversible adiabatic expansion of steam. Option number B, constant pressure heat addition process. Option number C, reversible adiabatic compression process, and option number D is given as constant pressure heat rejection process. Pump performs which process? Pump is used to give a pressure to some component, some fluid, and make it move for a displacement. That is the work of a pump. It converts pressure energy into mechanical energy or hydraulic energy, then mechanical energy to hydraulic energy. That is the operation of pump, process of pump. So it is giving pressure and compressing a thing. That is the concept of pump. What in compression process only you will be giving pressure. So I am going with option number C, reversible adiabatic compression process. This is the right answer for pump. Question number 15, what is the unit of heat rate? Option number A is given as kilojoule by kilowatt. Option number B is given as kilowatt by kilojoule. Option C is given as kilojoule. Option D is given as kilowatt. The right answer for unit of heat rate is kilojoule by kilowatt. Option number A, kilojoule by kilowatt. This is the answer for unit of heat rates. Today's section is over. Hope you like this video. Like it and share it with your friends. If you are new to the channel, please subscribe it. Thanks for watching, guys. Bye.